go. One that we're finding fascinating at the moment from Sweden, pictoglass, is basically a fritting that's actually applied when the glass is still molten. And this gives a kind of a stained glass effect. So for me, it's like a modern day stained glass. So what's good about that is often you have to put the fritting on the inside face, because on the outside face it gets dirty, and if it goes on the inside face, then you lose some of the colours, etc., because of the treatment to the glass. With this, because it's actually, the fritting actually happens while the glass is still in a molten state or semi-molten state, you can actually have it on the outside surface, so you can have some very true colours. Dichroic glass, so there are several projects in Dubai now using this. So this glass is in this picture, the glass is the same on all three buildings. So basically this glass will change colour depending on which angle you actually look. Double skin designs, also mentioned in the previous presentation by Lars. So we've been involved with some internally vented double skin designs which improve the thermal comfort, which is basically where but there's a lot of material you're using, so a lot of cost and a lot of energy cost in terms of the amount of material you're using for these double skin facades. So the trend we're seeing at the moment is the actual material being reduced, the double skin zone being reduced, and the idea of pressure. So basically a smaller cavity, pressurised with blinds in it. So we've seen this used in London. At the moment it hasn't been really used in the Middle East. I think you have to consider very carefully whether to use it in the Middle East given the conditions here. For me, one of the most important things in the Middle East is the fact that the sun, compared to northern climates, we're closer to the equator here. So the sun is higher for much longer periods of the day. So for me, the most efficient way of dealing with heat is to actually put in horizontal shades or some form of horizontal shading. Now, this is not a new concept. I brought this image out purposely because it was written in 1960. So some of the ideas that we've been looking at with clients and architects would be to actually bring in some horizontal elements into the facades and then put energy generating materials, possibly. Photovoltaic cells, to our understanding, are much better in a horizontal plane. So the studies we've been involved with, it hasn't made much sense to actually have photovoltaic cells on vertical faces of facades. So the idea of trying to use these horizontal elements to bounce light, to give a more ambient atmosphere inside, to angle the glass so you get less reflectivity on the inside. So try and look at the geometry rather than just applying a high-tech material, actually trying to look at the geometry and the materials together and marry them to try and get more benefits. Very new concepts, which I think are still in research, which we think are interesting. Algae producing facades. So this project's in Germany, where they actually fill the glass with algae, and then the algae grows and creates biofuel. That one's probably a long way off before it actually comes onto commercial building, I would think. This one, though, is much closer, which is the idea of using materials in the facades to help clean the air, which I think is a great idea. So these have got active components which actually help clean the air. So when you've got smoggy cities, adding or any cities, adding these type of materials, I think gives something good to the overall city or town, something back. And then finally, a very interesting one that's just recently come out from MIT in the US is the idea of photovoltaic cells which are completely clear. And then, so I think 2 more slides to go. Piezoelectric tubes, so the idea of having hairs on a building which will move with the wind and actually generate electricity. We think this one's very interesting. And my final slide, I didn't quite make it in time, the idea of LEDs on facade. So this project amazed me. This is in Korea, I think. I can't read from here. But they basically have cameras that take a picture of the building behind the building and then reproject that same image on the front end of the facade. So basically, the net effect is to make the tower disappear. I think what really amazes me about this building is it's next to an airport. So they're putting a huge tower next to an airport and then trying to make it disappear. So interesting technology, questionable use, I would say. So that's the end, and thank you very much for your attention.
So back again, we have the next speaker for the day who's going to talk on anchoring fasteners. Nobody better than Hilti as of today. We have Samir Koal, who will basically give you a little talk on the safety in facade fastening. Over to Samir, please.
Thank you. So it's Samir Kohi. I'm used to it not being pronounced correctly, but it's Samir Kohi, and indeed I'm the marketing head of Hilti here in Qatar. Just to give you a quick intro on Hilti, for those of you who don't know Hilti, it's a company that's based in a place called Liechtenstein. It was founded there. And I'm very curious to know, we got about 150 people in the room, I'm very curious to know how many of you have heard or know of Liechtenstein. That's surprising. Actually, I'm impressed. I'm impressed. Okay, good. It's a tiny little principality between Switzerland, Germany, Austria, and Italy. Nevertheless, it was founded there in the 1940s. Today, it employs over 20,000 people in 120 and some countries. And as you probably know, Hilti has a very wide portfolio of product. However, our modest contribution to the facade application is in fastening of the facade and in fire stopping the joints. This is where we play, this is where we contribute to this specific application. I've got two clickers here. Which one is it? That one. Okay, great. So what we're going to focus on today is on the first one. It's on the fastening of the facade, and a topic that Hilti has been putting a lot of focus on its entire existence, but really has been investing a lot into from an R&D perspective in the past decades, which is safety. The anchoring systems out there are only as good as the installation, and here we believe that this is an opportunity for innovation and a contribution to a sustainable and improved fastening of
Hilti explains the.
So what we're going to do is we're going to take it back to the basics and really quickly go over the basic working principles of anchors, of the different anchors most commonly used by you guys. Then we'll talk about the shortcomings in installation throughout the world and provide you some transparency into where the problem is occurring. And then we'll talk a little bit about some technologies and innovations that completely eliminate the risk for improper installation. Okay? So there's a couple different ways to fasten things to concrete. Anything, whether it's a facade or any other connection. You can embed elements into the concrete during pouring, or you can come after the pouring, drill a hole, and then use an element to fasten something to it. Okay? Now, in the facade industry, depending on the geography you're in, there's different preferences. Here in the Middle East, the most commonly used method is post-installed. After the concrete's been installed, we come back in, we drill, and we install the bracket. Within this method, you've got essentially three main type of anchors. Some that expand in order to get its capacity, some that create an undercut, and what we call bonded anchors, better known as chemical anchors. Okay, and these are the ones we want to focus the discussion on, simply because that's the most commonly used methods here in the Middle East. Okay? So I mentioned expansion anchors. Quite a few designers in the room, I'm sure you've dealt with these anchors in the past. This is an anchor that essentially, during installation, through a process called torquing of the nut, forces a large object into a small object, which creates expansion against the walls of the hole, hence friction. So the entire capacity of the anchor is obtained, which one am I supposed to push? Well, nevertheless, it's obtained through the friction of the expanding element into which a cone is being forced into during the torquing process, making torquing a critical step in the installation. The second working principle out there that's commonly used is called undercutting. And here it's essentially creating a void in the concrete where the anchor can expand into, and creating a mechanical interlock, which helps the anchor gain its capacity. Now this is generally very high performing anchors used for high structural loads, and there's many benefits of this simply because of the amount of stress you put on the concrete. You can have better edge distance and spacing, and so many benefits here, but largely used on the structural elements as opposed to facade. And then finally, what we call bonded anchors, which rely on adhesion in order to gain its capacity. Here, you drill a hole, you inject a chemical, you put in a rod, and you gain your capacity through a gluing process, okay? Here, the critical step in the installation process is cleaning. If the hole is unclean, it creates a fundamental problem in the ability of the chemical to gain its capacity. So that's kind of the basics, just to set the stage a little bit. Might be already knowledge for some of you, but just to make sure everybody's aligned. So what we want to talk about is where the problems are occurring. Hilti spends a lot of time going out to customers, going out to job sites, talking to specifiers to understand what the challenges are, where the shortcomings are. And we've done quite a bit of research in understanding in the context of safety, what's happening in countries maybe where the labor is not as skilled, on the other hand where the labor is skilled, to understand where the issues are during installation. And I want to talk about this. And we've come to some conclusions where we've decided to invest in development. What's important to understand is that the performance of an anchor is completely dependent on its what we call robustness. And this robustness topic is something that is supported by any internationally approved approval, like ETA or ICC, where before they publish any sort of performance levels, they will go through a battery of tests to test robustness. And robustness is essentially broken out into two dimensions. The first one, which is the condition of the concrete. Topics like cracked concrete, the strength of the concrete, they'll test it in different conditions to understand how the anchor behaves. And the second dimension, which we focus on today, which is installation deviation. How sensitive the product is to improper installation. So if the installer screws up one part of the installation, how badly is the capacity of the anchor impacted? And this is fundamental to translating into performance, okay? So I mentioned the two main solutions used in the facade industry here in the Middle East is expansion anchors and bonded anchors, with expansion anchors being the most common. And I mentioned how it relies on adhesion, on the gluing process, which gets highly impacted by the non-cleaning of the hole. So the process is simple. An installer drills a hole, is supposed to come back in, blow the dust out, brush it, blow the dust out again, brush it again, and do a third time for, in most cases, of blowing. Then he can install the chemical, which then will glue properly and gain the capacity. Now, when you go through this battery of tests in the context of ETA or ICC approvals, the result of not cleaning the hole is quite dramatic, down to about a third of the capacity. So with proper installation, you'll get 10 kilonewtons. With improper, it can go down to 3 and less. So significant impact. Now, we're all familiar with the labor throughout the world, and installing a chemical anchor takes a certain level of skill, which we don't always find in places like the Middle East. We invest a lot in training, but that's never enough, and hence the need for new solutions. Now, the second most, well, I would say the first most common used solution is expansion anchors, as I mentioned earlier, stud anchors, different names for it. Here, the critical process in installation is going to be the torquing. If you don't torque the anchor enough, you could have displacement. If you over-torque it, you could have breakage of the concrete. And again, a performance of 10 translates into not so much a lower performance when under-torqued, slight difference in the amount of total kilonewton, but significant displacement. So the anchor will settle because of the working principle. If it's not torqued properly, the anchor will pull out some before it catches on, creating an instability in the structure and potentially putting more strain on the other anchors that could lead to a failure. Now I've got a tiny small video here that I want to share with you guys to illustrate this point, simply because this is the most common used solution. It puts it in the context of a different application for hand railing, but the concept is the exact same. Very simple video, 2 minutes, just to kind of get you interested a bit here and to illustrate this point.
Hilti explains the importance of the right torque moment when installing expansion anchors. This is Tom. He is working in the constructive industry. His next assignment is the installation of a public balcony. He knows that a lot of people are going to visit that balcony. And he also knows that an expansion anchor is only working properly when the right torque moment is applied because of the working principle. Tom's top priority has always been safety. In order to secure all relevant parts that carry the balcony, he applies the appropriate torque moment. This may be a little time-consuming, but Tom knows it's worth it in the end. Because if he applies too much torque moment, the effect called over-torquing can lead to breakage of the concrete, which leads to time-consuming rework. Or the anchor is not able to work properly anymore because the segment is already moved over the cone area, and the anchor loses its dynamics. Not enough torque moment applied to the expansion anchor leads to under-torquing. This means that the base plate might become loose. The correctly installed anchors have to overtake the load from the one that is not working properly. As a result, the whole installation becomes unstable. Only when Tom applies the accurate amount of torque moment, safety is guaranteed, and that is just what he wants. Now the installation is done. Tom is very proud of his work. The balcony is a real eye-catcher, and most importantly, it is safe. The only thing Tom wishes for would be a tool that helps him to apply just the exact amount of torque. But that is all still up in the air. Outperform, outlast.
Okay. Good. Cute video, right? I drew all that, by the way. You guys don't believe me. You're right. So again, to illustrate the importance in the installation of expansion anchors and the right torque. The right procedure is for them to use a torque wrench and apply according to the instructions for use the amount of torque based on the diameter of the anchor, the embedment depth, etc. Now, as specifiers, there's a lot we can do. There's obviously the contractor side and installer side where they have to ensure proper installation. There's a manufacturer side where they have to provide products of a quality that allows for some room for error. And then there's this, and training, by the way, from the manufacturer side, but there's also the specifier side, which has the power to specify types of products that they know will ensure proper installation. And this is the solutions that we want to provide the market with. There's a couple of different ways to do it. You can either completely rethink the working principle. So here we talk about expansion and friction in order to gain your capacity. You completely rethink how everything works to eliminate the need for torque. Or you generate or create accessories that allow the installer to install the product properly without any effort or without any knowledge. And this is two dimensions that Hilti has worked on, and I want to show you some of these solutions, okay? So on the bonding chemical side of things, there are accessories out there, solution systems that Hilti has developed to ensure that during the drilling process, cleaning is done automatically through the development of hollow drill bits that are connected to vacuums. And as the installer is drilling, the dust is being pulled out so that he doesn't have to go through that extra step later and can't mess it up, essentially. Just injects the product directly, he's done. The next step above this is to, like I mentioned, completely rethink the process. And what we've done here is essentially taken a product that used to rely solely on gluing to a product that relies on both gluing and expansion. And that's what I want to take a second to talk about. It's called a HIT Z rod, and basically what it is a rod, and we've got some samples outside, feel free to take a look at them on your way out, that is shaped in a manner that will create lateral forces when a tension load is applied to the rod. So as the load is being applied and it's being pulled out of the hole, the shape of the rod is pushing towards the outside, the chemical against the walls of the hole, the borehole, creating friction, completely eliminating the need for cleaning. So now you can drill your hole, you can inject your product, you can install your rod, and the dirt inside the hole is actually sort of a benefit because it creates confinement. Again, completely eliminating the need for cleaning. Now the other advantage that this product brings is that it actually performs better than an anchor, a traditional anchor that is in a cleaned hole. So I mentioned earlier the impact of not cleaning the hole. Here on the left, on the right, is what happens with a regular rod when you clean the hole. That's your performance. When you don't, it drops to about a third, right? As I mentioned earlier. With the HIT Z system, eliminating the need for cleaning, you get a load, you don't clean the hole, you get the same load with a slight displacement, which is not critical, based on the fact that now you're working as an expansion anchor as opposed to a bonded anchor. Okay? Again, here, no skills required. You just inject product and you push a rod into it. On the mechanical side of things, as I mentioned earlier, expansion anchors being the single most used solution here in this region. Again, on the accessory side, we've developed products that ensure proper torquing every time without the need of a torque wrench. So this little device right here that you see, this laser is not working, but the upper one on the left, red little device, was actually taken from the automotive industry for tightening nuts on tires, on wheels. And all it is a device that you plug into a impact driver, and as you install the anchor, it will stop once the proper amount of torque has been applied. So the installer, all he has to do is press the trigger until it stops. That easy.